Good afternoon. Welcome. This is Chevjin Academy. Thank you for joining our live session. In today's lesson, we want to look at the cost comparison of Eurocode and the BS code. I'm sure we are all familiar with the two codes. Um, in our previous video, one of the latest video on my channel, so I've tried to look at the technical comparison between the BS code and the Eurocode for slab design for reinforced concrete structure. So at the end of the video, we come up with some design outputs. And then in that video, I promise to have a live session where we look at the cost analysis of both the BS code and the Eurocode. So today we are going to be looking into that. So before we start the live session proper, if you have any question as we go along with the class, you can just drop your question and then we try as much as possible to attend to them at the end of the video. So for this exercise, just like the previous video that I made, we are going to be working with a layout, this layout. So this layout, we have about 8 panels, but two of the panels are similar. So altogether, we have 4 different kind of panels. So for the purpose of this exercise, we are going to work with panel 1. So that means we design panel 1 only. So in that video that I made, which is a normal video, so we designed the slab with both the Eurocode and the BS code with a slab thickness of 150. But at the end of the design output, we saw that for the flexure check at 150 thickness, only the BS code method is what passed. Using the Eurocode, the slab fails the serviceability requirement on the flexion. So because of that, we want to design it in such a way that both the BS code and the Eurocode, we want to look at which one is going to pass out of the two. Which thickness is going to pass for either the BS code or the Eurocode, and then we now look at which one will cost more out of the two. So this is the layout we want to work with. So briefly, just to run through the loadings, we are going to consider the dead load and the live load only. So we are going to be having the BS code on the left hand side and the Euro code on the right hand side. We are going to look at the loading process for the two codes. So for dead load, first dead load to consider is the self weight of the slab. The self weight of the slab. So we assume a slab thickness of 150. So we convert it to meters. You multiply by the density of concrete, which is 24. So at the end of the day, you have 3.6 kilometer per meter square. Then for finishes, we apply a finish thickness of 75 with a density of 22. Then we also have partition. We assume a partition load of 2.5. So the next after that is service load. So let's just assume a service load of 0.5. So the total load based on the BS code for dead load is 8.25 kilonewton per meter square. Then according to the Euro code, the dead load is going to be the same thing, but the difference here is based on our previous analysis, we found out that at 150 thickness, the Euro code will not pass based on the slab size of 5 meters by 5.5. So we now want to go with a thickness of 175. And here, the density of reinforced concrete according to the Euro code is 25 mm. So that will give us an increase in self-weight of the slab from 3.6 to 4.38. Then finishes is going to be the same. Same goes for partition, service, and ceiling loads. Then the total load due to the increment in the self-weight, the total load is also going to be increased to 9.03. For the life load, we assume a life load of 3.0 for both codes. So because of this, we can now have a combination load. So this combination load is the load combination to combine both the dead load and life load together. So to do that, for the BS code, we have 1.4 dead load plus 1.6 life load. At the end of the day, we substitute our values. So we have design load of 16.35. For the Eurocode, the factor changes from 1.4 for deaths to 1.35, then from 1.6 to life load to 1.5. So in putting the value of our loads, we have the design load for the Eurocode is 16.65 kilonewton per meter square. So you can see that the loadings are quite similar, even though we applied different factors. We still have a we have a reduced number of loads according to the Euro code. The load from the BS code is slightly higher due to the density of concrete that has been increased and also the thickness of slab that we increased. So having understood this, the next thing is to analyze the slab. We have various methods of slab analysis, but since this video is just about the design and the cost implication, so I'm just going to look at the most critical moments out of the four moments in slabs. So the most critical one for the BS code is 22.89 kilonewton meters. For the Euro code is 23.35. You can understand that because the load is slightly higher. So from here, we can calculate the effective depth. The effective depth is calculated from the thickness of the slab, 150, minus cover to reinforcement. We allow a cover of 20 mm. Then we assume a bar size of 12 mm. So half of it will give us 124 mm. But for the Euro code, since you are using a thickness of 175, so the D is also going to increase to 149 mm. So once we're done with the analysis, the next thing is now to design for the bending reinforcement. So we are all familiar with this formula, 22 m over bd square FCU. M is the moment, B is the width of the slab, D is the effective depth, FCU is the characteristic strength of concrete. So substituting M 22.89 for BS code times 10 to power of 6, this is to power of 6, divided by B of 1000, D of 124 squared times 20. So you are going to have a K value of 0.074. From there, you can determine your lever arm, 112.8 millimeters. So the AS required will now be calculated from this value, M over 0.95 ZFY. So from there, if you substitute value of M, which is 22.89 times 10 to the power of 6, divided by 0.95 times 112.8, Fy here is the characteristic strength of the reinforcement, which is 410. So at the end of the day, we have an area of 521 millimeters square. So based on this design, if you want to go with a thickness of 150, the area of reinforcement we are going to provide is T12 at 125. This is what we pass the deflection check. Then for the Euro code, we substitute the same thing. Our moment now is 23.35. Then we substitute B of 1000. D is now 149 squared. So this 2 is to power of 2, not 190, 149 2. Is 149 raised power of 2. Then times 20. So this will reduce the K to 0.052. Then we can calculate a Z of 141.8. Then using the same formula, but in this case with a reduced factor from 0.95 to 0.87. This is to the Euro code. Then substituting for the area, you can now calculate the area required is 461.6. You can now see that the area required for the BS code is slightly higher compared to the area required to the Euro code. And this can be understood because we have an increased thickness of slab from 150 to 175. So to the Eurocode, we are going to provide T12 at 150. That will give us an area of 752. So now the critical part of the design, which is the check for deflection. To check for deflection, according to the BS code, the first thing we have to establish is the actual length to depth ratio. So the short span is what we are going to be using. The short span is 5 meters. The depth is 125 effective depth. So we have 40.3. So what we want to achieve here is at the end of the day, the limiting from the code must be greater than this actual for the deflection to be okay. So because of that, we need to calculate our basic ratio from table 26. From table 3.9 of BS 8110, we have 26. Then we need to calculate Fs from this formula by substituting the AS required and AS provided. Beta is always taken as 1. So at the end of the day, you have Fs to be equals to 157.4. In order to calculate the limiting, the modified for the limiting ratio, we need to evaluate m over bd squared, which is going to give us m. We know our m to be 22.89, b is 1000, d is 124. Substituting that, we have 1.49. So at the end of the day, the modification factor is going to be 1.66, which is less than 2 based on the code requirement. So what we need to determine now is the limiting basic ratio. So the limiting is equal to the basic ratio times the modification factor. This is the modification factor. Our basic ratio is 26. So this value must be higher than the actual. So at the end of the day, if you multiply 26 by 1.66, you have 43.2, which is slightly greater than the actual. So therefore, you can say that according to the BS code, providing a reinforcement of T12 at 125, the slab is safe for substability requirement. So let's now check for the Eurocode. According to the Eurocode, we need to determine what we call K. K is a factor of the type of support, that is the type of continuity of your slab, maybe continuous on one end or an interior panel, or if it's a cantilever slab. But based on our own slab, we have one long edge continuous. So this kind of slab, the K is 1.3. You can check the 7.4N of Eurocode 2. So, and then in order to calculate the limiting factor for Eurocode, we need to calculate what we call the reference ratio. This reference ratio is equals to 10 to the power of minus 3 square root of FCK. FCK in this case is 20. So if you substitute 20, at the end of the day, you have 0.0045. Then you need to evaluate what we call the rho. The rho is given by 100 AS required over BD. So we know our AS required. This one is for tension reinforcement. Based on our design, we only require tension reinforcement for the slab. So our rho is 0.31. If you substitute AS required of 461.6, so this is what you are going to have, 0.31. Then for compression reinforcement, because what we designed was singly reinforced, so the compression reinforcement is going to 0. So once we calculate K, rho, and rho prime, we can now evaluate our limiting basic ratio according to the Eurocode. There are some formulas to use, but I don't want to bore us with that formula here. You can check the Eurocode for the formula. It's quite straightforward. You just need to substitute your K, rho naught, and rho prime. So if you do that, you are going to get 14.43. But this value must be modified. So you need to modify it by multiplying it by the AS provided over AS required. This is AS provided, T12 at 150. Then AS required is 461.6. So at the end of the day, you have 23.6. Then another factor in which you need to use to multiply this basic ratio is what we call the reinforcement factor. Because this formula, the formula that you use to calculate the limiting, this formula is based on Fy of 500. So if you have an Fy that is less than 500, the code recommends that you use this formula. Whatever you got here, you multiply it by the basic ratio. So if you substitute Fy, our Fy in this case was 410, then AS required of 461.6 divided by AS provided of 753. At the end of the day, you have 1.99. So you need to multiply your basic ratio by the factor. Therefore, your final limiting now is not going to be the basic ratio multiplied by multiplication factor. That will be 23.5 that we calculate here, multiplied by the factor based on the strength of reinforcement we are using, 1.99. So at the end of the day, you have 46.8. So therefore, you can say, based on the Eurocode and the BS code, the deflection is okay, because the actual ratio of 40.3 is less than the limiting given by the two code. For the BS code, the limiting is 43.2. For the Eurocode, the limiting is 46.8. So at the end of the day, we can say our deflection is okay. So in summary, based on this design, we can see that for the BS code, the required thickness of slab is 150, while the reinforcement we provide is T12 at 125. For the Eurocode, the passing or the thickness of slab that passed is 175, but the reinforcement we provide was T12 at 150. So based on today's market, let us look at which one is more economical, because just looking at it, you can say, okay, slab thickness of 150 should be much cheaper than thickness of 175. Yes, that is true. But if you look at the reinforcement requirements, you see that T12 at 125 will produce more reinforcement than T12 at 150. So let us look at the unit cost of this slab of 5 meter by 5.5, and look at which one is more economical. Because theoretically we've seen that, based on research, we've seen that it is said that the Eurocode is expected to be more economical than the BS code. But based on this our design, it's hard to say. But let us look at it. So the cost analysis of this, we need to establish some parameters. The first thing is the cost of reinforcement per length. The reason why we are using per length is we don't want to start calculating the total amount of reinforcement we need. So once we can calculate the unit cost per length, then we can compare. So let's take in Nigeria's market today, this price is not absolute. So let's take that a 12 bar is 6,000 naira per length. 6,000 naira per length. And then the cost of concrete. So let's assume a standard strength of concrete of 20 mm. So 1 meter cube of concrete today should cost around 30,000 naira per meter cube. This is just from our assumed value. It is not the actual market representation. It can be slightly higher. So we are going to be having the cost analysis of the BS code on the left hand side and that of the Eurocode on the right hand side. So the first thing is the slab size. For the Eurocode, the slab that passed was 5 meters by 5.5 meters by 150. For the slab size according to the Eurocode, we have 5 meters by 5.5 by 175. I hope this is clear. So if you have any question, you can drop it in the comments. So the next thing, after we've established the sizes, you can see that the thickness is what differs. Here we have a thickness of 150. Here we have a thickness of 175. So the next thing is the concrete volume, the volume of concrete. So based on this size, the volume of concrete is expected to not be the same, because slab size of 5 meters by 5 meters by 150. So this one is going to give us a volume of 4.125 meter cube. Then for the Eurocode, the volume of concrete based on the design is going to be 5 by 5.5 by 0.175. So this will increase the volume of concrete to 4.8125 meter cube. So you can see that the volume of concrete from the BS code is slightly lower. So let us now look at the number of reinforcements we are going to have. In the short span, the number of reinforcement is going to be, the short span is 5 meters. 5 meters, we are neglecting the beam in this case. We are neglecting the beams. So 5 meters divided by the spacing of your reinforcement, that will give you 40, but you need to add 1. So we have 41. For the Eurocode, the spacing of reinforcement is 150. So therefore, 5 meters divided by 150 will give us 34. 33.33, you approximate uh, to the to an O number of 34. 34 number. Then along the long span, the size of the long span is 5.5 meters. So it's 5.5 meters. So at the end of the day, we are having 5.5 divided by 125. So that will give us 45 numbers. Then for the Eurocode, since the spacing is not the same, so 5.5 divided by 150 will give us number of 37. So this cutting length of this reinforcement is going to be virtually similar or the same or very close. So because of that, we are just going to now calculate the rebar, the total cost of reinforcement. We are using per length. We don't need to evaluate the length because this is the cost per length. So we just know the total number of reinforcement times the unit cost per length. So this one is going to give us 516,516,000 naira for the reinforcement. Then according to the Eurocode, because the spacing is slightly higher, we are going to have a lesser cost for reinforcement. So we save more. That will be 34 plus 37 times 6,000 naira. So we are going to have 426,000 naira for cost of rebar according to the Eurocode or reinforcement. You can now see, even though the Eurocode tends to give higher thickness of concrete, the spacing is reduced. So therefore, you can save more on the reinforcement. So let's look at the cost of concrete. For concrete, we assume 10,000 naira per cubic meters. So based on the BS code, we have 4.125. So if you multiply that by 30, for one panel of 5 meters by 5 meters by 0.15, you have 123,150 naira. This is to the BS code. Then according to the Eurocode, we are going to be having 4.8125, which is the concrete volume, multiplied by 30,000 naira per cubic meters. So you have 144. So you can see that the volume of concrete according to the Eurocode is slightly more compared to the BS code, but the reinforcement is slightly reduced compared to the BS code. So now you can now do the total. According to the BS code, the total cost of reinforcement and concrete, we are neglecting labor cost and some other things, even though all other things will be partially the same, only for the form work. This is 150 and this is 175. So let's go with total cost. If you add up the cost of reinforcement and concrete, you have 639,750 for the BS code. And then for the Eurocode, the total cost is going to give us 570,375 naira for the Eurocode. So you can see that even though the volume of concrete is higher, you are saving more on the reinforcement. So it depends on the market, so you can know. So based on this calculation, you can see that you are saving roughly about 130,000 naira just from changing. Instead of using the euro code, you decide to use the BS code. You've saved 30, almost 130,000 naira is what you saved. Sorry, no, you saved about not 130. What you saved is around 70,000 naira. That's what you saved. So now assume that you have this panel about in 10 different, like the panel that I showed you, the layout, we have about 8 panels. So let's say based on the Eurocode design, you saved 50,000 naira per slab. So that will be 400,000 naira is saved just because you use Eurocode instead of the BS code. So you can see clearly that the Eurocode seems to be more economical compared to the BS code design. So if you want to learn more on design either to the BS code or to the Euro code, you can check out the link in the description of this video. So I left a link on manual design to the Euro code, manual design to the BS code. So you can check it out and start learning how to design all your structural members from the project inception phase to the design of to structural layout to the design of each members, starting from the slab, the beam, the column, the staircase, the foundation, and also the detailing of these members. So you can check out the course, or you can look out for us on our website. So you can contact us from here, chefgenacademy.com, or you can message us via this WhatsApp contact details or via our mail. So based on this exercise, you can see that you can now see the cost comparison of the BS code and the Euro code in terms of slab design. Well, this does not really give the whole picture, because if you want to compare the cost analysis of the two code, you have to look at a lot of things. Sometimes based on our design here, you can see that the BS code requires less thickness of slab. But based on the deflection requirement of the Euro code, it tends to increase the thickness of the slab. And because of that, you have higher depth in your slab. But because the depth has been increased, you can try as much as possible to provide a more economical reinforcement. So if you now juxtapose it and put it side by side at the end of the day, you see that the design is almost the same thing, but using one code to the other, it tends to save more in some other aspect. Like in terms of the BS code, you save more on the concrete. And then in terms of the Euro code, you can save more on the reinforcement. So if you have any question, you can leave it in the chat box. So I'm going to reply to them. So this is the end of this lesson. So you can ask your question by sending your message to the now. So I'm going to give like 15 minutes for question and answer. So if you have any question, you can drop it in the comments. And then I want to say sorry for, because I put out a link before, but at the end of the day, I don't know what happened. The link couldn't connect. So I have to recreate another link. So maybe that is why the turnout was low, because I've already sent out a link like 2 days ago. But unfortunately, I don't know what happens. The link was having issues. So because of that, we couldn't use the link. But this video is going to be recorded, so you can at the end of this section, you can still rewatch it, so that if you miss any parts. So it seems there's no question. So thank you guys for joining this live section. I really appreciate your time. So you can also leave a comment and tell me which other video you want us to make, because on this channel we want to be making live session every month. The plan was every first week of the month, every first Sunday of every month. But last week Sunday we are involved in other things, so we couldn't meet up. So that's why we shifted it to the second week of this month. So in the first week of May, we are going to have another live session. So if you have any topic you feel you want me to discuss about extensively, you can leave it in the comments. And if it's if it's something that we can discuss, then we are going to discuss it. So thank you. If there is no question, I really appreciate your time. Thank you for joining this meeting. See you next time.